Hello everyone. In this video, I'm going to talk about examples involving continuous random variables. We'll look at a joint density and an example involving independent random variables. So here's the quick overview. For the first one, we're going to actually calculate an expectation of x using integration by parts. This will give you just practice evaluating integrals that come up in the continuous random variable section. The second is a little bit of a follow-up. We're going to calculate a probability, x greater than 2, using integration by parts. We'll take a look at a joint density example, and the last one will be an example involving independent continuous random variables. So for the first example, let's say we have a PDF that looks like this. You can see, if you remember, this is an example of an exponential random variable PDF. So let's say we have this 3e to the minus 3x for x greater than 0 and f is 0 otherwise. Suppose we wanted to find the expectation of x. So to find the expectation, we need to integrate x times f of x. So here's our solution, right? This is sort of what we see in general, x times f of x. Here, we know that the random variable is defined, or not 0, for x greater than 0. So we integrate 0 to infinity. 3 times x times e to the minus 3x dx. So to evaluate this integral, we need to use integration by parts. You may remember this formula that I put up here in the top right corner. This is what we need. So we'll let u be equal to this x, and we'll think of dv as 3 times e to the minus 3x. Then it's easy to find du, the derivative. We see du is equal to dx. And to find v, we integrate over here. We simply get v is minus e to the minus 3x. So the integral that we need to calculate becomes uv minus x times e to the minus 3x, evaluated from 0 to infinity. And then we get a plus. There's actually a double negative going on over here. And we have the integral 0 to infinity of e to the minus 3x dx. So when I evaluate the first parts, we end up with 0. Right here I have e to the minus 3x, x going to infinity. So this will be 0. And then down here I'll have minus and x equals 0. So this whole thing becomes 0. When I evaluate this integral, we'd have to make a u substitution, but we end up with a minus 1/3 e to the minus 3x. So again, when x is infinity, this term will go to 0, and then I'll have minus the result when x is 0. So I'll have the two negatives give us a positive, and we end up with 1/3. So e of x is equal to 1/3 for this PDF. In the next example, it's somewhat similar, but suppose we have a PDF here. F of x is now 1/2 x squared e to the minus x. Again, this is for x positive. F is 0 otherwise. Now suppose we wanted to just calculate a probability that x is less than 2. So I suggest here, this is a great problem to practice. Stop the video. Try to obtain the answer. Good practice of integration by parts. And my hint here is you have to use integration by parts twice but you probably already knew that since we had this x squared term here. Okay, so going over the solution, I would start by setting u equal to x squared over 2, and dv is equal to e to the minus x. We could put a dx here if we wanted. I left it out, but dv e to the minus x dx. So when we start using the formula for integration by parts, this is my minus uv term. We have to integrate this from 0 to 2, and then I have plus the integral 0 to 2x e to the minus x dx. And you can see here we made some progress. This is now just x instead of the x squared we had over here. So this is where we would use the integration by parts now the second time. All right, when I evaluate this term over here from 0 to 2, you'll see that we get minus 2 over e squared, right? And this is what we would get from this 2 term. Right, I would have minus e to the negative 2, so that comes downstairs in the denominator. And then we have up here to be a 4 over 2, so that's how we end up with a 2 in the numerator. When x is 0, this term just goes to 0. So this term here simplifies to minus 2 over e squared. When I work out this integral here, this will be my uv term again, using integration by parts. Limits from 0 to 2. And then I'm left with plus the integral from 0 to 2, e to the minus x dx. So I'll skip a step or two here, but did you get this as a final answer, 1 minus 5 over e squared? Or 0.3233. So hopefully you did, which is excellent. All right, I have another one for you to try. Suppose x and y have constant density on the square where x is between 0 and 4, y is between 0 and 4. Find the probability x plus y is less than 4. So one more time, stop the video, try to obtain the answer, and you probably realize that you need to find the PDF first. Okay, finding the PDF for a joint density, well, that's going to be simply 1 over the area of our region. A 4 by 4 square has area 16, so we get the PDF is 1 over 16. Now, we have to think about the region x plus y less than 4. So remember, we are in the first quadrant, the region x plus y less than 4. If you wanted to graph it, I suggest that you draw the first quadrant, and then we have this line x plus y equals 4, or solve it for y. Y is 4 minus x, and we want the region x plus y is less than 4. So using that, we could figure out our correct bounds here. Right? Remember we said y is 4 minus x. So this would be the integral 0 to 4, and the integral 0 to 4 minus x. This would be 1/16. Let's say dx dy. Somehow the dy is missing here, but that's not a big problem. All right, so we work out that integral. It's easy to see. We'll get 4 minus x over 16 dx. We have to evaluate that from 0 to 4. So we get 1/2. Did you get 1/2 as an answer? Excellent. All right, last example for this video. Suppose we have an emergency occurs and the response time in hours of the first police car is a random variable with density 12e to the minus 12x. Of course, this is for x positive. The response time for the fire engine is also a random variable, let's call it y, with density 10 times e to the minus 10x. Let's assume x and y are independent. We want to find the probability the first police car arrives before the first fire engine. So in essence, we want to find the probability that x is less than y. Okay, so now we could use some of our tools. We need to calculate this integral. So here I want to look at the integral, and this would be sort of as y goes from 0 to infinity, and then in here the integral from 0 to y. Now, I wasn't given a joint PDF, but I know that the random variables are independent. So the joint PDF would be the product of these two. These basically are what we call the marginal PDFs. Okay, so this is how we'd set up the integral using the joint PDF. Okay, but now we could separate this a little bit, and we could express this first integral. I could take the terms with y out. Okay, when we integrate with respect first, we treat this part as a constant. So I can take this outside of my integral when I'm integrating with respect to x, and then work out this integral first. Integral 0 to y, 12e to the minus 12x dx. Okay. When I do that, my result would be 1 minus e to the minus 12y. Remember, y is this upper limit. Okay. Now I work out this integral with respect to y. So at this point, to make this a little bit easier, I would take the 10 outside the integral. I would use a distributive line here, so this becomes e to the minus 10y. Then minus, when I multiply these two terms, e to the minus 10y, e to the minus 12y, same base, add exponents, so I get e to the minus 22y dy. So we could work these out even as separate integrals. You'd have to use a u substitution to work these out. I would suggest try working this out from this point, and our final answer should end up being 6/11. Okay, this concludes the video. I hope you find it helpful.